In this section we're going to talk about parabolas and circles, and we're going to go ahead and review parabolas really quickly because we've seen them before. We have y equals ax squared plus bx plus c, which is the quadratic form of a parabola that opens either up or down. A will tell us whether it opens up or down. If A is positive, it opens up, and if A is negative, it opens down. And recall the vertex can be obtained by the formula x equals negative b over 2a, and then whatever this is, we go plug it back into the function or the parabola to get the y-coordinate of the vertex. Then we had y equals ax minus h squared plus k, which is either called the vertex or the standard form. And the vertex can quickly be obtained by just pulling out the h and the k. A has the same rule as it did before, and remember, if A is bigger than 1, your graph is narrower, and if A is less than 1 but greater than 0, your graph is narrower. Wider. Your graph will be wider. If A is, let's write that down. So A bigger than 1, your parabola is narrower or skinnier than the basic one. A less than 1 but still positive, your parabola is wider. And of course, if A is negative, the same behavior, but it opens down. For example, let's do a quick sketch of this parabola. We know the vertex is the opposite of the inside, -3, and the last k value, -2. And we know that it opens, if A is equal to 2, it opens, it's bigger than 0, so it opens up, and it's also narrower than your basic one. So a quick sketch would be go to -3, -2, and make a parabola open up. If you needed more details like the x and the y-intercept, we could go find that as well. So for the y-intercept, we would make the x 0, plug it in here, and it would give us a y value of 16, it looks like, which means the y-intercept is way off our graph, thus making your parabola sort of narrow. For the x-intercept, we're going to make y equal to 0. So right here, set the y equal to 0. And we can isolate the squared quantity, so I added 2 to both sides and I divided by 1. Now I'm ready to square root it. So I set the equation, the right side of the equation, either to a 1 or a -1. I solve that, and it looks like we get -2 and -4 for our x-intercept, so we can go get a more accurate graph. And there's our more accurate graph, and of course if this goes up and up and up, it'll hit the y-axis at +16, it looks like. And we found our x-intercepts by just letting the y value be 0 and solving that equation that could be solved by the square root property rather than having to multiply it out and use factoring. It was quicker to find it this way. Next, we look at the circle, and to do so, we first analyze the distance between 2 points, and we look at 3 different scenarios. We're going to keep it in quadrant 1 just to make the numbers simple. Let's say I want to count the distance between these 2 points. If it's a horizontal line, it's easy. 1, 2, 3, 4, 5, 6. So the distance is 6 units between 2 and 8, and notice that's just 8 minus 2, which gives me a distance of 6 steps. Or if it's a vertical line, it's also easy. 1, 2, 3, 4, 5, 6. This is also a distance of 6. Or if you think about the y values, that's a y value of 7. And at the bottom you have a y value of 1, so that you have 7 minus 1, which gives you a distance of 6. So if it's straight across or straight up and down, all I have to do is just count my steps. Whereas if it's slanted like this, then I can't just go 1, 2, 3, 4, 5, 6 unless I have a ruler that measures by these units. So what do I do in this case to find the distance? I can say, let me find an imaginary point that makes a triangle, like let me put it there, for example. And if I do that, then this horizontal segment and this vertical segment will be easy to find the distance for. Notice that'll be 1, 2, 3, 4, 5, so that's 5 steps, and the other one, this is 5 steps, that's 6 steps, and I can see that that makes a right triangle, so I can use the Pythagorean formula to find out what that distance is exactly. So I can say that distance d, for example, is going to be 5 squared for one leg 6 squared for another leg, all under the square root for the Pythagorean formula. So we have an exact distance of square root of 61 units, or approximately 7.8 units. So we were able to achieve finding the exact distance of the slanted line by simply using the Pythagorean formula. Now let's make these points general. I came up with a random x1, y1 and a random x2, y2. And with these coordinates, I'm going to guess what the coordinates of this ordered pair must be. Well, it's along the same y value as this first ordered pair. So I go this many to the right and y1 up, so the y value must be y1. And it's also aligned right under this ordered pair, which has an x coordinate of x2, so I must have gone x2 to the right to land there or there. They have the same x coordinate, so that's an x2. Now I have this corner ordered pair in terms of the other random 2 ordered pairs I made up, and that'll help me give this segment's distance and this horizontal segment's distance. So for this vertical distance, I have y2 minus y1 to get the vertical distance, and for this horizontal distance, I have x2 minus x1 to get this horizontal distance. And now I can find this distance, red distance, using the Pythagorean formula of this vertical distance and this horizontal distance as my legs squared and added. And that gives us the distance formula. So the distance between any 2 points is just the difference of their x's squared added to the difference of their y values squared under a square root. So if I need to find the distance between these 2 ordered pairs, I call one of them my first set, the next my second set, and then I can just look at the difference of the x values. The order doesn't matter. And the difference of the y values, again, the order doesn't matter. And simplifying that will give me the distance. So the distance between these 2 ordered pairs is 5 root 2. If I were to plot them and count my steps, I will have gone 5 root 2 steps to get from one point to the other. Now we ask the question, how does a circle get formed? It basically gets formed from a fixed center, and we keep the same distance and plot points all the way around. For example, if I want to make my center be this ordered pair, then I have to keep the same distance all the way around that ordered pair in order to make my circle. So the distance d, or in our case the circle, we call it the radius, is the same all the way around. So no matter what ordered pair xy I choose, from the center, which we call hk, the distance is always the same. So we can use the distance formula for these 2 ordered pairs. So we say the distance stays fixed to be the radius. Our ordered pairs are a random x and the fixed center h. That's why we call it a specific h as opposed to another variable. We want to make it seem like it's fixed, whereas the x varies. And then y, which varies, minus a fixed k, which is the center. And this basically says that all those ordered pairs from the center have the same distance r. And if we go ahead and square both sides, we get the standard form of a circle. And if I have a circle in standard form, then it's going to be very, very easy for us to graph it. We plot the center, we take our steps all the way around our steps, in other words, the radius, and then we got the circle. Let's find the center and the radius of the given circles in standard form and then graph them. So we know these clearly compare to the standard form of the circle. So for the center, we're going to pull out, like the parabola case, the opposite of what's inside the parentheses, +2 and -3. And for the radius, we always take square root of that number on the right because the original formula has an r squared in it. And since it's a radius, it's always going to be a positive distance. So we go graph the center, +2, -3, and then we take 4 steps in all directions. 1, 2, 3, 4 up. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. 1, 2, 3, 4 down. And then the other directions too, but if you just do these 4, it's going to be good enough. And connect the dots in a circular manner, and you got your circle. Same thing for part B. Notice there's no number as my h and k there, so the center must be 0, 0, because the h and the k are missing. And then the radius is the square root of whatever's on the right, which is a 3. So the center is at 0, 0, and we take 3 steps to the right, 3 to the left, 3 up, 3 down, and we've got our circle. And if on the right side you don't have a perfect square, you can always approximate what that number may be and take your steps in the directions as needed. Next example says find the equation of the circle in standard form. By looking at these two, we know standard form requires us to find the center and the radius, and then we're good to go. Let's look at part B because it's easier. We know the center is at 0, 0. And then the radius, we're going to count to see how many steps and how far we go. It's easiest to go to the right for me, so it looks like I've gone 6 to the right, and also 6 up, 6 left, and 6 down, so the radius must be 6. Therefore, I have x squared, since the center is 0, 0, plus y squared equals r squared, which is 36. And that's our equation in standard form. Part A, notice the center is going to be 1, 2, 3, 4, 5, 6. So this is a 1 and 1, negative 2. So center is 1, negative 2. And then the radius, it looks like it's a 2. So our equation must be x minus 1 squared plus y, the opposite of that, plus 2 squared equals r squared, which is 4. So we plugged in the 1 and the negative 2 into the hk. The double negatives here made it a positive 2. And our radius is 2 steps, so that's going to give me 2 squared, which is 4. Sometimes we're not given a circle in standard form, and if it's not in standard form, we're going to use the idea of completing the square on both the x's and the y's to get it in standard form, therefore being able to find the center and the radius easily. So let's find the center and the radius of this given circle. We know this is a circle because there's an x squared and a y squared involved, and the leading coefficients are both identical. They're the same number 1. They could have been 2, 3, 4, 5. As long as they have the same coefficient, it is going to be a circle if both quantities are squared. So what do I mean by completing the square? You're going to take the x's and leave them there, and you're going to take the y's and leave them there, and you're going to take the constant and always move it to the other side because your goal is to get the standard form. Then you're going to do the half business on both of these. So we did the half business on the 6, and now we're going to use the 9 and add the 9 to both sides of our equation. Because it's an equation, we have to keep it balanced. Then we did the half business on the negative 4y term, and now we have to add this 4 to both sides of the equation. Now that allows me to factor the left hand side as x, remember the number you saved, plus 3 squared. So x plus 3 gives me this trinomial. Plus I can factor this into two binomials, y minus 2, whatever number you got there, squared. So y minus 2 gives me that trinomial. And then simplify the right side and simply add them, which gives us 1. Negative 12 plus 13 is 1. Now we have it in standard form, so the center is negative 3 and a positive 2, and the radius is just the square root of 1, which is 1 anyway. So we took something that looked sort of ugly and not in standard form. By completing the square, we got it in standard form. Let's do another one. Find the center and the radius of this circle. Notice they're both x squared and y squared, and they have the same leading coefficient of 2, which I actually don't like. So I'm just going to divide everybody by 2, because I would rather deal with a leading coefficient 1. Now I'm going to move the constant to the other side and complete the square. For the x's, we're going to add 4 to both sides of the equation. For the y's, we're going to add 16 to both sides. Then we're going to go ahead and factor each term. This is going to be x plus 2 squared. Same thing here. Y plus 4 squared. Add the right side, and it looks like we get a 15. So our center is negative 2, negative 4 pulled out of these guys, and our radius is square root of 15, or approximately 3.87.